The area model? What the heck is that? It's just a fancy way to multiply, guys. It is the box, okay? It's just really fancy. So the first thing we're going to do is we're going to multiply the 2 and the 4x so we can put our answer right there. We get 8x squared. That's because 2 times 4 is 8. And the x squared just stays because there's no x over here. Next we go 2 times 3. And we do not get 3, we get 6. So I got to fix that. Hold on. Okay, that's better. We get 6 because 2 times 3 is 6. Okay, now pretty much this is essentially the same thing as the rainbow because we're going 2 times 4x squared, which is right here. And then we go 2 times 3, 2 times 3. And so we can write our answer out down here. So whatever you get inside of the area model, you just write out with plus signs and then you're done. Okay, let's try another one. Whoa, this guy looks a little crazier. All right, so this time we have 2 binomials. We have a binomial here because there's 2 terms, and there's a binomial here, 2 terms. Last time we had a monomial and then a binomial. So this time the area model looks a little bit bigger. We end up getting 4 terms. Okay, so for the first one, we're going to multiply these 2 together. 2 and 6 is 12, and v times v is v squared. Next, we're going to multiply these 2 together. So we have 6 times -1, which is -6, and then we throw the v in there. That v doesn't change because there's no v on this term. The next one I'm going to do is a 2v times the -2. So I get a -4v. And then the last one I'm going to do is -2 times -1, which is a +2. Because when you have 2 negatives multiplying, you end up getting a positive. So all you got to do now is write out all of these in the box. But you'll notice that these 2 terms are the same terms. How do I know they're the same terms? Because they have the same variable. This one has a v squared, so he's not the same. This guy does not have any v's, so he's just a constant. So he's not the same as those. But these 2 guys are the same, so I'm going to end up adding those guys together. So we have 12v squared, and then I add those 2 v terms together to get -10v, and then we have a positive 2. Just like before, this is the same as the rainbows. Okay, if I go 2v times 6v, I get the 12v. If I go 2v times -2, I get the -4v. And then we have -1 times 6v, and then the last one, -1 times -2. The only difference is this in this box. If you do the rainbows, you're probably writing it out like this. For every one of those, you write your term. But then you see you have 2 like terms, and you would combine those, still get the same answer. Another way you can write this, if you do your own box, it might look like this. And then you fill in the sides like so. We have 2v minus 1. We got that from the first part. And then you put the other one down the side. And then you fill it in just by multiplying. So it's pretty much the same thing as the area model. In fact, the box method is the area model. And then you see the 2 terms that are the same that you would have to add together. So that's how you do that one. All right, one more. Ooh, doggy. They just keep getting bigger and bigger. Okay, so I'm going to multiply these 2 first. You'll notice that this polynomial right here, the c squared minus 6c plus 2, that's all right here. C squared minus 6c plus 2. So it's just like the box method going on here. So I get -c to the 3rd power. If you're bothered that there's no numbers in front of these variables, remember you can always throw a 1 in front of those, and that will make you feel better. Next, I'm going to do the c squared times 3, and I get 3c squared. Next, I'm going to do the -c squared, -c times -c, -6c times -c. So that's going to be a positive 6c squared, and we get c squared because we have to go c times c. There's 2 c's, that's why there's a c squared. Next, I'm going to go -6c times 3, which will give me -18c. Then let's do the 2 times -c. Remember, there's like a -1 right there. So I'm going to put a -2c because -1 times 2 is going to be -2. And then I have 2 times 3, which is going to be 6. I write it all out. But first, let's notice that we have some similar terms here. We have 2 c squareds right here. We have 3 and then 6. So we're going to have to add that up. And then we have 2 c terms. We have a -18 and a -2. So when I write it out, it's going to look like this. We have -c to the 3rd. Then we have 9 c squareds. Then we have -20 c's and then a +6. like before, I'm going to show you guys the rainbows. Okay, we got lots of rainbows here. This C is going to have to, or this C is going to have 3 rainbows coming out of it. That's the first rainbow. And then there's a second rainbow. And then there's a third rainbow. So we got 3 terms from that one. And then when I do the 3 guy right here, I'm going to get another 3 rainbows. There's 1. There's 2. Where's the second? Come on. Second rainbow. There's 2. Okay. And then here's a third one. So there's a total of 6 terms still. This time I would have to notice that the like terms like this, they're not right next to each other, kind of like that. I have to add those together, and then I have to add these together. Okay, my box that I would set up if I was doing this myself would look something like this. I would put the 3-term polynomial on top, the 2-term on the side. That's a trinomial on top. That's a binomial. Two cool vocabulary terms. And then I'd fill it all in. After you fill it in, you can see that there's the C squareds are kind of right next to each other, just like the area model, and the C's are right next to each other. And that's how you do that one.